So for number 18, a lot of you were distributing in the fourth power first. You're going to get huge numbers if you do that. It just depends on who you had for Math 1 and Math 2, how they taught you how to do it. You can do it either way. Me and Miss Allred used to bare knuckle brawl about this ish because she likes to distribute first. And I don't know why, because you get huge numbers. I always have simplified the inside first because I teach a lot of Math 1 and I have to teach them PEMDAS, and parentheses always come first. So we do the inside first. Really doesn't matter, but you will get smaller numbers if you do the inside first. So 5/20 reduces to what? There we go. Y'all sounded so excited because y'all are like, we know how to do this. X cubed divided by X. Remember, when you're dividing, what do I do with my exponents? Subtract them. So do you guys agree this is X squared now in the numerator? All right, and then y divided by y to the 5th. There's more y's in the denominator. 5 take away 1 is, there we go. Wherever there's more, that's where your answer will end up. Did your Math 1 teacher show you why that works? Oh my God. I don't like it when teachers don't show y'all where stuff comes from, because then you think we're just making crap up or that you have to memorize something. There's no memorization. Look at this. How many y's are left in the denominator? 4. Yes. Same thing with the x's. If I had 3 in the numerator, 1 in the denominator, where are 2 left? The numerator. So this is called expanded form. I wish they had shown you that. I wish I could just teach everybody everything. That's okay though. Yeah, probably. All right, so from here, now we're at the point where we can distribute in our exponent. It is outside of parentheses, so it's going to go in to every base in the parentheses. Notice I said every base. It also goes to the 1 and the 4 because they have an understood 1 as their exponent. Very good. So did you guys get, I'm going to move this right here, 1 to the 4th, x to the what? 8. Good. Remember, when you're distributing, we do what operation? Multiply. Beautiful. 4 to the 4th and y to the 16th. Okay. And so 1 to the 4th is just good. So this is going to be x to the 8th over 56, right? 256. Y to the 16th. Cool. We remember doing this in Math 1 and Math 2? Definitely Math 2. I know a lot of you took Math 1 in middle school. Can you move it over? I sure can. Right there.
Does the 1 on the top have to be there?
It does not have to be there. So this is another thing. Just depends on who you had. They might have told you if you put a 1 that's not simplified. Did anybody ever tell y'all that? Also a lie. Not a lie. They're wrong. I'll go tell them they're wrong to their face so you can tell me who said it. You can put the 1 because even if the 1 isn't there, we know there's an understood what as the coefficient. A 1. So I don't care if you put it or not. It's the same thing. I don't like it when they say that. Same thing with 1 being an exponent. If you want to write it, go for it, because whether you can see it or not, is it there? Yes. I did a whole research paper on that in college. Y'all are like, how the heck do you do a research paper on math? You get creative. Who said that? Extra credit. I liked that. I'm going to use that. That was good, Kevin. See, you should go into something math related. All right. For this one, I think we might have freaked out because we saw the negative exponent, but also because there were parentheses with nothing outside. If there's not an exponent outside, you don't need to distribute. So this is just like saying this. What operation are we doing? You're multiplying. So what happens with my coefficients? What is 5 times 2? Good. Now I'm multiplying. That's what you guys just told me. So what do I do with the exponents? Okay. You all just heard yourself say add, right? when we get to our last example in our notes today, do not tell me multiply. What did you just say? Okay, cool. So x squared and x to the fourth makes x to the sixth. Okay, and then y to the first and y to the negative third should make y to the negative second. Good. And then what do we do from here? Oh, they're so excited. They're like, yes, we know how to do this. And make it positive, right? Did anyone ever explain to y'all why you can't have negative exponents? Not imaginary. Not necessarily. What did you say? Yes and no. Because if they're not real numbers, then they have to be imaginary. Kevin, if I told you to go run around the track -2 times, what would you do? Okay, walking backwards is still going around the track twice, though. You're just going the opposite direction. If I told you to go run -2 times, what would you do? Yeah, that's called time traveling. That means like previously you would have already done it. Does that make sense? That's not a thing. If your mom said go clean your room -3 times, the heck does that mean? No, you can't do that. You can't have negative time, so we cannot have a negative exponent. Okay, this is my junk. I did my research paper on exponent properties. Love it, so that is why. Sound good? All right. Man, I wish I had y'all for math too. That would have been a fun class. Not that I didn't love your class, Taryn. Because I did. You know who I miss? I miss Trace Baker. Someone tell him I said hello. That is my boy. -2a to the third, b squared, c to the 0 over 3a squared, b to the third, c to the seventh. And then we will be done and we will move on and we'll take it to the pre-cal level. Don't be scared. Not really. All right, what should we do first? Yeah, you can distribute first if you want. I'm going to simplify the inside because it ends up being one step easier, okay? Can we simplify -2/3? Nope, so I'm going to bring it down. All right, talk to me. We're dividing, so what do I do with my exponents? Okay, so what's 3 take away 2? Good, and I'm going to put the 1. Does it matter? No. All right, look at your b's. Where are they larger? Okay, so we're doing 3 minus 2 from the denominator, not the bottom. Bottom sounds like butt. 3 minus 2? 1 in the denominator, good. And how many c's am I going to have left? All 7 in the denominator. Bottom. I don't let my math 1 kids say bottom and top. Then it sounds like you're talking about butt and boobs. Not school appropriate. All right, from here, what do I do? Okay, you could flip it. I don't flip it. I wait to do all the flipping at the end. Why are you telling me we can flip it? Because you can do it now if you want. If you have a negative exponent, you're supposed to flip, right? So I save all my flipping for the end because the ADHD is real and I'll flip something now and forget to flip something else. So I just save it for the end, okay? You could go ahead and switch your numerator and denominator now. But if it's okay with y'all, I'm just going to distribute this in to every base. Does anybody have an issue with that? Okay. So this is -2 to the negative second, a to the negative second, 3 to the negative second, b to the negative second, and c to the negative 14th. I just multiplied. And now what Kevin just said, all my exponents are negative, so I'm going to have to flip everything, okay? So the denominator, not the bottom, is coming to the numerator. Slide this over. And then the numerator is going to the denominator. And we're making all the exponents positive. And then what's the last thing you should do?
Square.
Good. Square the numbers. 3 squared is 9. B squared C to the 14th over 2 squared. Good. And it is -2, but look, the -2 is in parentheses. -2 times -2 is still a +4. There we go. So you guys remember your exponent rules. Now you do. Good. That was the whole purpose of this. So exponent rules are not a pre-cal topic. I need you to understand that. So on your test, you are not going to see one of these. In the types of problems we do in pre-cal, though, because we're getting into our exponential functions unit, a lot of times there will be different bases with exponents that are multiplying or dividing or being raised to another power, and you have to know what to do with those, okay? So you do need to know your exponent properties. What questions do we have? I'm doing awesome on time. Notes should not take more than 15 to 20 minutes tops. I'm hoping 15. Are we good to go ahead and move on? Okay. So I do want that worksheet that y'all just did, and people at home, hopefully you did it on paper or in your notebook. I do want that in your notebook. So we are going to label a page for that, okay? Okay. Thanks for answering me, Taryn. I appreciate it. All right, we are starting a new unit. Whoop, whoop. What'd you say, babe? I'll bring y'all tape after we do notes, and you can get it in there, okay? Exponentials, logarithms, and logistics. Hopefully, I'm just making sure we all get 100 on our notebook check. Hopefully you labeled this yesterday like you were supposed to. People at home, just make sure your Unit 1 test review gets put in on page 7. Or you label the work you did in your notebook for your test review, page 7, okay? Let me move y'all down here. And then I can do this. I miss teaching at the board. I don't like sitting. All right, so your first topic was properties of exponents review, and that's where that worksheet will go. And let's not call it, okay, let me ask y'all, do you want every unit to renumber the topics, or do you want to start off where we left off? Okay, how about you do what makes sense in your brain? If you want to renumber, go for it. I need to continue it because that's going to really bother me. So I'm going to call it 8. If you call it 1, you're not going to get points off. Do what makes sense to you, okay? Because we are all different. Properties of exponents review. So that's where that warm up will go. And then today's topic is solving exponential equations with like bases. Is that better, Cody? Is it because I used blue on blue? Okay, solving exponential equations with like bases. I won't use the blue anymore. So I need to skip a page after my test review. for that warm up. So there's that, and then I will pass around tape and staplers after notes, so you can get that in there. All right, what's an exponential equation? What? An equation with an exponent. Beautiful. Ding, ding, ding. But more specifically, what will be in the exponent? Good. The variable. Is everybody with us there? Okay. So an exponential equation. Can you see the green okay? Okay. An exponential equation. What did I write? Yep. Are just equations that contain exponents that have a variable. Exactly what you guys said. All right, so there is a property of equality for exponents. So I am going to write it out for you guys. But then we'll talk about what it means, because I bet a lot of you have had teachers write this in the past, and then this was like your notes and you had no idea what it meant. So we're going to break it down. B to the x equals b to the y, and x equals b to the x equals b to the y, then x equals y. Good. I'm hearing some O's. I'm hoping we learned this in Math 3. If I have two expressions that have the same base, then that means I can set their exponents equal to one another. Okay? That comes from this theorem, this property. So that's called the property of equality. Now, the b greater than 0, b not equal to 1. I'm going to get into that tomorrow. So are you guys okay if we just table that for tomorrow? I will tell you why it has to be bigger than 0 and why it can't be 1 tomorrow when we talk about exponential functions, okay? But what you need to know is if the two bases are the same, then I can set the exponents equal. Does that make sense? Do I need to write that out in English and not math? Or are y'all okay with this? We're okay. All right, so let's do an example. That was your notes for today. Now we just got examples. Cool. All right, 2 to the 3x minus 3 equals 2 to the 9th. All right. The bases are the same. Do we agree? Okay. So when the bases are the same, we know we can do what with our exponents? Set them equal. That's what your property just said, right? If b to the x equals b to the y, then we can set x equal to y. Okay. Here's why. If you type 2 to the 9th into the calculator, you're going to get a number, right? Well, basically, if this side says 2 and we're trying to make them equal, then that means this exponent also has to be 9, right? 2 to the 9th would equal 2 to the 9th. Does everybody agree with that? So look, if we do 3x minus 3 equals 9, how would I solve for x? Add 3 to the other side and we would get 12, and then divide by the 3 and we would get 2. Do we remember this from Math 3? That's okay. If you don't, does it make sense? Okay. Because you guys didn't do as hard of ones in Math 3 that we're going to do today anyway. So, doesn't matter. I have to reteach it anyways. We go with the first one. All right. I'm only probably going to do one more where they're equal, because I don't feel like we need to spend all day doing that when it gets harder. But y'all let me know. 5 to the 6x minus 4 equals 5 to the 4x plus 8. Online people, if you have a question, speak up. Or leave. Somebody just left. It's about to get a whole lot harder, so I hope they come back. That's 4x plus 8 if you're having trouble seeing it. All right, my bases are the same, which means I can do what? Set what equal? The exponents. Make sure your phones are parked so that you are paying full attention so that you understand your homework. So 6x minus 4 equals 4x plus 8. What do we do now? Good. Get the x's on the same side. That was the test problem. That's still about a fourth of you missed, even though we've done it probably 20 times now. Get the x's on the same side. On the test problem, you had to get the y's on the same side, right? So subtract the 4x over is what Cody said. So Cody, what do we have now?
2x minus 4 equals 8.
What do you do with the negative 4? Add it over. So 2x equals 12, which means x would be what? Good. Now, in a perfect world, this will work all the time. Do we live in a perfect world? No. So please, 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 please do me a favor on your homework and also on your quizzes and also on your tests. Y'all need to be substituting these answers back in and making sure they work. Okay? Because I'm telling you right now, on your quizzes and tests, I will put one where one of the answers does not work. Do we know what it's called when one of the solutions doesn't work? Yes. Yes, say it, girl. Say it again. Extraneous. Extra. Doesn't work. You should have learned that in Math 2 and Math 3. Okay? So I will put one where there is an extraneous solution. So make sure you are checking. So to check this, you would just substitute the 6 back in for each of the x's, right? I'm having to teach my Math 1 kids how to do this right now, and they act like it's the hardest thing. And I'm like, babies, plug it in. Your brother likes to do it in his head. You're like, yes. Sounds right. 6 times 6.
36.
Minus 4. 4 times 6. Plus 8. Did it work? Sure did. Cool. Just make sure it works. Because if it's extraneous, that really means there's how many solutions? No solution. Very good. Extra credit. All right. So sometimes the bases will not be the same. What do we do if the bases aren't the same? There's two options. You always check option 1 first. Ooh, you're almost there. Not a common denominator. What are we talking about? Bases. Is everybody with me? Option 1, you try to get a common base. It is very similar to a common denominator. Good job, Chloe. Get a common base. And then just a rule of thumb for your common bases, guys. Your bases should always be integers or whole numbers, okay? We're not trying to make our bases fractions, thus getting a little wild, all right? So make it a whole number if you can. You will be able to. So basically make it a whole number. It's not a if you can, you should be able to, okay? All right, if you cannot get a common base, does anybody remember from Math 3 what we'll do? And we're not doing it today. All of your ones today on your homework, you can get a common base. What do you do with an exponential equation if you can't get a common base? How would you solve it? How would you be able to bring the exponents down? Oh, I'm so sad. Not square root. Exponentials. Do y'all remember logs? ln, natural log, log, that's okay. Okay, that's fine. I will reteach you. Thank you for letting me know that. I will add that in. Logs are the opposites of exponents. They basically undo exponents. So if they're opposites, what are they called from the first unit? Ding, 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 inverse functions. If you cannot get a common base, and this is what we'll be doing next week, we'll start this next week, then your option 2, but we're not doing it now, so I'm going to put not now, would be to take the log of both sides. Because then what you're going to learn with me, I freaking love logs. That's the first thing you're going to learn. If you take the log of both sides, then you can bring the exponents down in front of the log. It's pretty cool. And I'll show you why. You know I got to show you why, okay? That's what you would do if you can't get a common base. But what did I just tell you we'd be able to do today? Get a common base. So let's look at an example. I'm going to do probably 3 to 4 more examples, maybe just 3. It depends how much y'all get it, okay? All right, so 4 to the x equals 1/2 to the x minus 3. Are the bases the same? So we need to try to get a common base. Now, please remember what I just wrote down with you. It needs to be a whole number. Should 1/2 be the common base? Y'all, there's nothing you can raise 4 to make it look like 1/2. Somebody every year always says 4 to the -2, that's 1 over 4 squared, which is 1 over 16. Not the same. So what common base could we write 4 and 1/2 as? This is where you have to think. Okay, a couple of you just said it. What'd you say? Not 1/2. Remember, we want it to be a whole number. Say it again. 2. Look at this, because you're like, what the heck? What is she talking about a 2? If we write 4 with a base of 2, it would be what? 2 squared. Good. 2 to the second. So look at this. I'm going to rewrite this as 2 squared, and then there was an x up there, right? Okay. Now I'm thinking this is why Grace said 2. Do y'all see how 2's in the denominator? If it's in the denominator, then what did I raise it to? Negative what? Good. 2 to the -1. That's my common base, the 2. And then we already had x minus 3. Why did I put the x minus 3 in parentheses? It's 2 different terms being multiplied by the -1. Very good. That's how you get a common base. I will start to teach you some tricks. Like, if it's a fraction, always see if the denominator can be the base. Okay? So really look at 2 and 4. What would be the least common base? It would be a 2. Are y'all okay with that? So now that my bases are the same, what do I do with my exponents? Good. So 2x should equal -1 times x minus 3. What would I do next? Distribute. So 2x equals -1x plus 3. All right, Cody, what do I do next? Good. -1x over here. So this would now be 3x because you would add it. Equals 3. So what does x equal, y'all? Beautiful. Believe it or not, this is not where y'all mess up on the test. This is, which kills me. Pre-calc kids always be getting the hard stuff right and the easy stuff wrong. If the bases are already the same, please don't miss that. Set the exponents equal. Are we okay? All right, can I do another one? So you would plug it back into the original up here to check it. It does work though. I made sure all the ones for the notes work. So if y'all feel good with substituting back in, then I'm not gonna waste my time doing it. Let's see. That's too easy. That one is okay. I'm just gonna do 2 more if y'all are good with it. That is a 27. I didn't tell y'all I had a math 1 kid roast my handwriting the other day. Daniel's little brother was like, your handwriting's good. I was like, I know. She's just being petty because she did bad on her quiz. His little brother. All right. Are the bases the same? Okay, the trick I just taught you. Look at the denominator of the fraction. What's the denominator? Can I write 3 to somehow end up being 27? Okay, I like what I just heard. I heard 3 to the 3rd times -x. Good. Which means we're actually writing it with a base of, oh, why did I put it over here? And y'all let me. Sorry, that's because it should be 3 to the -x and y'all let me. So I'm gonna ask again. I had a blonde moment. It's okay, see, even your teacher makes mistakes. What did you say we could write 27 as, Grace? 3 to the 3rd. But where do you guys see the 27 is at? Denominator, not bottom, denominator. If it's in the denominator, it's not 3 to the 3rd, it's 3 to the, no, -3rd. Do you guys remember that? If it's a negative exponent, that's when it moves to the denominator. So if the 27 is in the denominator, this would be 3 to the -3rd. Very good. 3 to the -3rd. And then 2x plus 5. So let's backtrack really quick because I think I confused a lot of you because I just wasn't paying attention. That happens sometimes. This already has a base of 3, correct? So between 3 and 27, the least common factor or the least common base would be a 3. Do we agree? So I'm going to leave the 3 and try to write this with a base of 3. So 3 to the -3rd is 1 over 27 because it would be 1 over 3 to the 3rd. Are we okay with that? Are y'all sure? Because some of you are looking lost. Or is that just our natural faces? Okay, that's fine. All right, bases are the same. What do I do with my exponents? Set them equal. So I've got negative x equals. Are y'all okay if I go ahead and distribute? Negative 6x minus 15. All right, Cody, you're going to be my person. What do I do?
Add 6x.
There we go. Get the x's on the same side. So this would be 5x equals negative 15. So what will x be, y'all? Very good. Can we do one more? Yeah, I feel like y'all probably need to practice one more. And I'm going to let y'all try it. So you guys try this one. And then we'll be done.
I have a question.
About this one?
About what steps can I get rid of?
Okay. Ask me that later when it's just me and you.
Okay.
All right. All right. So for this one, remember my trick. Look at the denominator. The denominator is 16. Correct. Did you guys look at 4 and 16 and say, okay, what's the least common factor? 4. Good, right? Or greatest common factor, I should say. Least common multiple is 4. So that means we should be able to write this 1/16 with a base of 4, correct? All right, think about 16. 16 is 4 to the second. It's in the denominator, so really we should put 4 to the negative second. Did y'all get that right? Wow, I'm so proud. 4 to the 3x equals 4 to the negative second. What would I do with my exponents now? Set them equal. So I have 3x equals negative 2. Good. I would divide the 3 and you do get negative 2/3. And you can leave it just like that. And if you plug that in, it does work. Because the 3's will cancel. And it's just 4 to the negative second, which is 1/16. How do we feel with that? Do we feel okay? All right, now look at me really quick. On your homework, can you guys look? Don't pack up yet. Look at your homework. Can you guys look at 3 and 4? Because I just know somebody's going to text me or email me about those. Look at 3 and 4. What am I doing with my bases? What am I doing? Multiplying. So what do you do with the exponents? Please don't multiply them, add them. Okay? You just add the exponents when you're setting them equal.